Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at the examples of significant figures. These are some basic examples designed to get your feet wet as an introduction to the concept. So the first rule is to show you that all non-zeros are significant. So here this one has 3. These are trailing zeros after the decimal point. Those are all significant as well. So if you count this non-zero and these 2 trailing zeros, you got 3 there. Here we have trailing zeros as well as a decimal point, so all of those zeros should be significant. And here the non-zero number 1, so 1, 2, 3, 4, 5 total. Now here you see that there's no decimal point right there. So because there's no decimal point, only the 4 is significant. So trailing with no decimal. So this would be one significant figure. Okay? Make sure you just keep an eye out for these basic rules. Non-zeros, if it's trailing with a decimal, or not having a decimal. Real quick, let's do one with scientific notation. I did forget to do that, sorry. So let's take a look at, I don't know, 4.020 times 10 to the negative 5th. Well, basically you just look at all these numbers here, all right? If they took the time to write that extra one right there, it's included. This is in between the 2 sig figs, so it's included. So here we have 1, 2, 3, 4 sig figs. Okay, so let's look at some operations examples now. If we have, for instance, 2.5 times 10. Well, how many sig figs does 2.5 have? Well, these are both non-zeros, so they're both significant. This one's a trailing 0 to the right of a non-zero with no decimal, so it's not significant, and there's 1 sig fig there. What that means is your answer should have, when in multiplication, the rule is the least number of sig figs in your answer. So if you were to multiply these two, you just move the decimal over 1 unit and you get 25, right? But that's 2 sig figs. You only need 1 sig fig according to the rule. So what do? Well, you got to round this using your rounding rules. So the first sig fig we come across is 2. Okay, so we got to change that last one, or change the 2 based on what this last number is. If it's 4 or below, keep the 2 the same. If it's 5 or above, change the 2 to a 3. So when we change the 2 to a 3 in this case, we now have 1 sig fig, and we are compliant with the rules for multiplication. I'm just going to use SF from now on for sig figs. Here, if you're using division, the same thing applies. So count the number of sig figs in each one. So here we have 3 SFs. And then here, oh, no, I'm sorry, I lied to you. Here we have 2 SFs. Reason being is because that 0 is not significant. Trailing zeros without decimals. That's the rule. Okay. So then here we have a couple of more trailing zeros without decimals. So there's only 1 sig fig here. And the rule for division is the same as multiplication. Use the least number of sig figs in your problem for your answer. Okay, so both of these had 1 as the smallest number of sig figs. So in this case, when I divide this, I'm going to get 3.5 as the initial response, but that has 2 sig figs. So what I have to do is round this 3, and because that's again a 5, we go up to 4 point, or just 4, sorry. Now, had this been a 4, it would be 3, or any number 4 or less. You would have kept this a 3. But because it's 5 or higher, you make this a 4. All right? So with addition subtraction, what you do is you look at the numbers to the right of the decimal. Here we have 2. Here we have 1. So we just take the 1 as the units for your answer. So when you add these two, you're going to get 5.40. But since this only has one number to the right of the decimal, your final answer would be 5.4. Okay? So multiplication, division, the least number of sig figs. Addition, subtraction, you use the smallest number of sig figs to the right of the decimal. I hope that's clarified things for you in the fundamental look at some examples of significant figures. You're going to need to practice a few of these, and then they'll become second nature, just like everything else in life. Thank you, and have a nice day.